Alright guys, I was going to go over a couple of the examples from the notes today. I was going to do example 5 and 6. So example 5 says, write the first three terms of a geometric sequence, graph the sequence. Remember we were talking about in class, if it says graph the sequence, that means do not connect the points. We just want these, it only asks for the first three terms. So we want to know the first term of the sequence, the second term of the sequence, and the third term of the sequence. We're given this equation. I had suggested to you that we can use our calculator. So we're going to go into our y equals, clear out what's in there, and we already have y equals here, so we just need to put the second part. If you're using Desmos, you still have to put the y equals. So it's 8 parentheses, 1 divided by 4, raised to the x. So if I want to know if x is 1, I'm going to go look at my table of values. Second graph gives me my table of values. Here's where x is 1, so my y value is 2. If x is 2, y is 0.5. And if x is 3, y is 0.125. So the calculator is done for you. It's plugged in, it did all the work. It plugged in the x values into this variable spot and solved for the y's. Okay, so these are the only 3 points that need to be graphed because we're just graphing this sequence, and we only ask for the first three terms. So this is 1, 2, so we go 1 up to 2. 2 only goes up to a half. And 3, I'm not sure where that is. I'm going to estimate it's like kind of like right in there. I'm not going to get a magnifying glass out and check your work, as long as we're kind of realizing that it's going down. Alright, so we had a little review session about domain. Remember, domain is your x values. Well, I was being discrete here, meaning I'm not connecting, so I'm only interested in those 3 x values, 1, 2, and 3. And when we have a discrete set, we use set notation with our French scrolls. Okay, we did this before. Our range, we're not talking, this is not going on for never, ever, never. It's only these 3 values. Range is your y values. Those are the only ones that I was interested in. So it's 2.5, 0.125 for our range. Now the equation for our asymptote, remember we said it's always y equals and then whatever the asymptote is. So we could use our calculator table and see what happens as the graph comes down. Is it going to pass this line or not? But remember also, you can look in your equation. Here is where it'd say plus or minus k. It doesn't say anything at all. That means it's not moving up or down from 0. So your asymptote will be where y is 0, which is the x-axis. Your graph will not pass that line. Okay. Increasing or decreasing, there's a couple ways we can look as they're going. They're getting smaller. That would be decreasing. We could also tell by our common ratio or our b value here. That will tell us that it's decreasing. So our graph starts off bigger and it's going to get little, so this is going to be a decay. And to find the 5th term, that means where x is 5. I could either keep this pattern going, or I could go back to my calculator and go to where x is 5. And I see it's 0.0078. 0.0078. So that means way out here at 5, it is so close to the asymptote we can't even draw that close. Our pencils are too fat. Alright, so flip this guy over, and we are going to talk about example number 6. Alright, so example number 6 says a geometric sequence has a first term of 6 and a common ratio of 2. So if we're going to draw this out, I know the first term is 6, the common ratio is 2, which means the second term is 12, the third term is 24, the fourth term is 48. I'm just following the pattern of times 2 each time. I do times 2 there, I'll get 96 for the 5th term. It says write the function to represent the sequence, and so we're writing the sequence. So the sequence says for any term, we have to take the first term times the common ratio, and then n minus 1. So I'm going to plug in what I have. And my first term is 6. The common ratio is 2. And then n minus 1. The part B says we want it in exponential form. Well, that's y equals a sub 0, this is in your notes, okay, times r to the x. So earlier in the notes, this information's there if you need to go back and look. So my exponential form will be y equals a to the 0. Well, I don't actually have that. It's right here. I need to know what this term is. Okay, so this way, I was multiplying by 2. To go the opposite way, I'm doing the opposite thing, which is dividing 2, but can be written as multiplication. It's 1/2. You're multiplying by 1/2. So, and if you follow our pattern, half of 24 is 12, half of 12 is 6, half of 6 is 3. That's my 0th term. That's what I need to put here. So 3. The multiplier is still 2, your common ratio, and this will be raised to the x. So even though these look differently, when I put them in the calculator, they will graph as the same line. All right, so we have, it says graph the function. Function means graph all the points. I didn't give you any limitations, so we're going to connect them together. Now these notes are on an earlier page, so go back and double check them if you can't remember what I'm talking about here. And I have some of the points here, but let's just kind of look at this real quick. So we're going to go into y equals, I'm going to put both of these equations in and remind you how they are, even though they look different. This one is starting where x is 1. This one is starting where x is 0. The function starts where, at the y-intercept, its start value, and with the sequence, we always start where x is 1. That's why when we first started down here, we started the first term, and we had to move it back to go to the function. So we have 6 times 2 raised to the, I have to use x because that's what the calculator has, x minus 1. And this one is 3 times 2 raised to the x. And so when I hit my graph button, watch what's going to happen. First, I'm going to get the blue line. Here comes this first equation that I did, and then following right along on it. See how the red line follows right exactly along in turns. So both lines are now graphed. They are the same graph, even though their equations look different, because one starts where x is 1 and one starts at the y-intercept. Okay, but graphing the function, we're going to graph all the points. So I'm going to go look at my table of values. That's the second graph. And I could, if I wanted to, go back to -1. If x is -1, you can see, look, how their y values are the same. Y is 1.5, which is somewhere I'm estimating. If x is 0, y is 3, so it's going to be a little bit higher. If x is 1, y is 6, so that's just past the halfway mark. X is 2, y is 12. If x is 3, y is 24. So I'm just kind of estimating for each one of these. 4 is 48. 5 is 96. So that's going to be as far as we're going to be able to go on this graph, 96. Okay. And I'm supposed to connect them because I'm graphing the function. It's just going to keep going. We just ran out of graph. It will keep going this way because we ran out of graph. We didn't have enough graph to write all of that on there. This question doesn't ask it, but I want to talk quickly about the domain and range on here, because on the other one, we listed them out specifically because these were discrete. But once you connect them with a line, you're talking about every single point in between, so that's our interval notation. So domain, remember, is your left to right. So when I look on the left-hand side of the graph, it's never going to stop going left. So back over there is where x's are negative infinity. So it's going to start in negative infinity. and it never stops going to the right, well, x's are positive infinity on the right, so it's going to be negative infinity to positive infinity. Okay? Our range, we need to look, if we look at the equations, I've got no plus k value here. There's nothing there. That means my asymptote is right here on the x-axis where y is 0. So y is 0 is the asymptote. That's where it's going to begin. And it's never stopping going up. So it's going up and up and up forever. And y values up there are positive infinity. See, our domain is negative infinity, positive infinity, and our range is 0 to infinity. So hopefully this will help you answer all of the homework questions, and I'll see you tomorrow in class.